last week what I did was I looked at doing sample playback in Max for Live using the objects buffer to store an audio file, Groove to play it back, and doing some kind of maths around making the audio play back at the correct tempo, which I'll review and quickly rebuild. But the bottom line is you can do that stuff in Ableton anyway, so why would you build a Max patch to do that? And then the reference point here is Fortet, Kieran Hebden, talking about his live setup and doing a little bit where he clicks with the mouse in Cool Edit to create the sort of glitchy, semi-random kind of effect. And so I'm going to replicate that in Max for Live. So let's really quickly recap this. We need to first of all decide what kind of effect it's going to be. I think it's going to be an audio effect because it plays back audio. And so we create a new empty audio effect from Max for Live. It could be an instrument because that will or also create audio, but that implies that there'll be some sort of MIDI control over it, which perhaps there might be, but I think if I get time to do this today, I think it'd be interesting to try and do something along the lines of creating a live audio input to this sort of chopping up device as well, so that as well as being able to load and play back samples, you could work on live audio. So if I get around to it, I'll demonstrate that too. So we'll open the Max editor. I'm hoping that everyone's able to spend a little bit of time looking at this, and those of you that are working on the free trial of Ableton, hopefully you're able to keep that running until August. So yeah, try and spend a little bit of time every week just sort of opening up the editor and trying to build a few things. I'll build this in edit mode, but I'll wrap it into a presentation so we can see what the final device looks like. Let's just tidy up a few things here. So I'm not interested in any of that stuff. All I want is the plug out. We need something to store our audio, which, if you remember from last week, is the buffer, and the buffer needs to be named. So let's call the buffer 4, or in honor of Fortet. So buffer plays back the audio, buffer stores the audio, and Groove plays it back. So Groove gets linked to the buffer by simply giving it the same name. So by calling Groove 4, that links it to the buffer object. And then we need to decide how many channels the Groove's going to have. Typically, you're going to be working with stereo samples, so we give it 2 channels. And then that gets connected to the output there. Don't know why those cables are so long. Okay, now we need a method for loading a sample into the buffer, and the method is replace, which we type into a message box. We can just keep that on the patcher and press it, and that will bring up a file selection dialog, but I'm more into the idea of replacing the sample using a drag and drop method. So we use replace, and then we use $1, the $sign in Max standing for a variable. So we'll pass in the path of the sample into the message and then onto the buffer using a drag and drop interface. The drag and drop interface is going to be called live.drop. And then that connects there. Now, live.drop won't do anything until it won't work properly until we save the device, because it needs to know where it is in order to find out where the audio is. So what I'm going to do is save this, and I've created myself on my hard drive. I've created myself a Max for Live development folder. And you can see a previous version of this in there. So I'm going to call this, for want of any kind of imagination, Fortet Slicer. Now what I can do is find an audio file like this one, drag it on there, double click my buffer, and we can see we've got our audio file, and I can play it back through Groove. In order to make Groove work, we need to provide it almost like a power, which we do using the SIG object, which is not any of that stuff. SIG just provides almost like if you imagine how a turntable works, you know, like a Technics turntable, you provide it with a DC voltage to make the turntable go. It's just that, really. So that goes in there. Which immediately plays the audio, which I'm assuming goes out to the stream there. To subsequently make Groove play, we need to send it a message, start loop, and then it will start playing. And then to get it looping, we need to turn its loop attribute on, which we can do in a couple of ways. We can either go to its little pop-up and select the loop option here, so we get a little attribute tick box here, and so that'll turn looping on and off. I would prefer to see a user interface element that interacts properly with Ableton Live. So I would use a live.toggle, which I'm going to put up there, to turn looping on and off, and we'd connect that to another message box that said loop, and then $1 for the variable. You notice what I'm doing here is I'm putting all my user interface stuff up in the bit that's going to display in Ableton. We can sort of see it happening down here. So every time I press save, new bits and bobs appear here. In a little while, we will start working on the presentation so we can actually see something a bit more graphically interesting. Okay, so we can load a sample, we can play it back, and we can set it looping. Let's just check that the looping works. Excellent. Okay, so to create this clicky thing that we're going to click on and select parts of the loop, we're going to need an object that will display the waveform of the audio, which is waveform tilde, which will immediately, when you create it, turn itself into a box like this. We can't now type arguments in, so what we need to do is send it a message to tell it to link to the buffer that we've just loaded the sample in. So we send it the message set, and then type in the relevant buffer name. Now, this is going to start getting quite messy because I'm going to be sending a lot of stuff into this waveform object here. So what I could do is use a send object. Let's call this two-wave. So this is like a wireless send and receive thing. So we have a send object and a receive object. Again, like the buffer, they're just linked by name. And then I can send the message set for to the waveform and receive it up there. So now anything I want to send to the waveform, now I could just send to this send object or another instance of it, and that message will be sent to the waveform object. So I'm not dealing with loads of cables splurging all over the patcher, at least for now anyway. Now the waveform object needs to be set so that I can select areas in it, and so if I go to the attributes drop down here for waveform, we can see that we've got a set mode attribute here. If you can see the problem, right? If I check this out, it says set mode 0 is do nothing, set mode 1 is select. So I can, if I set the mode to 1, I can select areas on the waveform object. So rather than do that, what I'm going to do is use the message set mode 1, send it to the waveform object, and I can now select areas in waveform. And we can see how this is going to start working out, right? So I'm going to be able to click different parts of the waveform here and have it play back different bits of the sample that I've thrown in there randomly as I click the mouse. To get this basic operation working, what I need to do is send the selection start and end points from waveform off to Groove. So these two outputs here, this one, selection start, this one, selection end, we can send into the Grooves loop minimum and loop maximum inputs, so that, provided looping's turned on, when I start the loop, whatever I select on the waveform will be whatever plays from Groove. All right, well, let's see if that works. It does. Okay. There's a few sort of niceties that I need to add in here to make this a little more usable. I think it would be good if we could make the sample stop as well. To find out how we do that, I'm just going to go to the Groove object and check the messages. And here we've got a message stop. So I'll make a stop message. So now hopefully I can start and stop the device. However, these things don't have buttons associated with them, so I need to put some buttons into the user interface. So let's just tidy this up a little bit. Let's start labeling things. So I've chosen a color scheme. I don't know why I've done this. I've chosen a color scheme in Max that's entirely black and Ableton. If you notice, there's actually how the Max editor inherits the Ableton color scheme. So I need to make it very apparent, because it's got a black background, using some white text, what each control does. So this is a comment box here, which you can create typing C in your editor. And I'm just going to change the text color for the comment to white. So I can call this loop on off. To start and stop the thing, I need to create some buttons. So I'll use live.button objects for that. So start. We'll go to start loop. And stop. We'll go to the stop message. Let's see if this works. So if I press start, and stop. stop. That does a thing. Let's turn on looping and press start. That kind of works. Okay, great. It's kind of important that we can, once we've created just the user interface for the device, it's important that we can, it will initialize itself correctly, so that any little bits of the device that would, if I open it to edit it, require me to click on to make it do something. Those things I can't interact with them once the final device is created. So I need to make sure that everything that the device needs to do to kind of get itself working happens automatically, and anything that I need to interact with is there visible in the presentation. So yes, for the curious, that is the old Thames Television ident back when I was a kid. It's another 80s reference, sorry. There was a fairly ropey looking kind of opening ident for shows that were on ITV at the time, which was I think it was Tower Bridge coming out of the Thames with that ident. I quite like it because it's non-rhythmic and it works quite well for this forte exercise. Anyway, so what I'm going to do now is go into the Patcher Inspector. So we go to Edit. No, Dan. We go to View Inspector Window, and then we find the option where it says Open in Presentation, and then we add everything graphical to the presentation. So the waveform, the user interface objects, and the drop area. We right click on them and choose Add to Presentation. And then we can have a look at the presentation by clicking down here and activating presentation mode. So that is what the device will look like. Now if I save it, jump across to live, I can save and close this thing. We can see that everything graphical, everything interactable, we now have there in the user interface, and all the other patching stuff has been disappeared. So if I grab but also notice, because live has kind of reloaded the device, that it's cleared out the buffer. So I just need to check that that's still working. So if I drop the sample back on there, it appears in the waveform. And then hopefully I can make it go. All right, wonderful. That could be running alongside some beats and other stuff in Ableton. And I suppose if I wanted to, I could send the audio off to another track and record my random clickings. But there isn't a thing that exists already in Ableton, as far as I'm aware, that would let you do that. And I don't know about anyone else, but I've always had a little bit of fun doing this thing where you start a loop selection and make it smaller and smaller and smaller, and the pitch goes up. It's kind of fun. Cool. All right. Now, when I load the device back into the editor, it defaults to presentation mode because I told it to open in presentation, so I just need to turn presentation mode off to get back to my patch. Let's have a little think about how we might, first of all, control the loop start and endpoints with some dials, and then how we might choose to randomize the start and end points so that we could perhaps kind of create a randomness programmatically. the first thing's relatively easy. On the waveform object here, we've got selection start and selection end, which we can use to set the waveform's start and end points. So if I wanted to do that, I can do that quite easily with a dial. So let's make a dial, live.dial. In fact, we're going to need two, aren't we? One for the start point and one for the end point. Perhaps I could even call them, before I go any further, start and end. When you make live dot objects like this that interact with Ableton Live's automation system, you need to make sure you give them the correct name. So you're naming them for your user so that the user knows what they do, but you're also naming them for Live's automation system, so that if you go into clip automation or arrangement automation, you'll be able to create automation curves for these objects. Okay, I need to know how long the sample is, because I need to know how big to make the dial. So what I need is the info tilde object for the for buffer. This will give me a variety of different bits of information about the buffer that I've got loaded. What I'm interested in is how long it is, total time in milliseconds, and that's what's displayed on the waveform object. Let's see if I can find out what that is. So if I send a bang command into the info object, what it will do is spit out a little number there that is the total length of the sample. I can have that automated because the right-hand output of the buffer here says it will bang when a file read operation is complete. So I can send that into the info object. Let's put it over here to make it tidier, so that if I loaded a new sample, like that one, it will immediately report the sample's length. Okay, that's all well and good. What we're doing here is creating controls that have a set and unchangeable start and end point. By which I mean, once we've made these dials and the patch is working, we can't subsequently go in and change the start and end values for the dials. They'll be fixed. So we need to figure out a way of making it so that regardless of the length of the sample that's loaded in, the dials still work in a meaningful way. The way I would tackle that would be to make the dials of style float, so they output floating point values, that's values after the decimal point, and we give them a range 0 to 1. What that means, in fact, we can take away the value. Now, what that means is that these dials will output numbers from 0 to 1. To get them to select a range in the waveform relevant to the total length of the sample, we can multiply that output with the value that we've established from info, i.e. we multiply the value from the dial 0 to 1 by the sample's total time, so that, for example, in the case of this one, which happens to be 4,900 blah-de-blah samples long. If the dial is at 1, it will be that number. If the dial is at 0, it'll be 0. And if the dial is halfway, 0.5, it'll be half of that. So it kind of scales the dial's value into something useful. It's a really good trick in general for being able to deal with kind of user interface elements like that that adjust variable things that you can't predict in advance, like the size of a sample. So we send each of these into a multiply. I'm going to initialize the multiplies with a value 0, and then I'm going to send the total time here into the right hand inlet of these multiply objects, and then I'm going to send the output of the dials into the left hand inlet, and then I'm going to cable the start point to selection start and the end point to selection end. Let's just go over that. Why did I initialize the multiply objects with a 0 dot? Because I want to make sure that they operate as floating point operations. If you don't do that, you'll end up rounding all your values to the nearest integer, which might not be an issue for something like this, but since I could potentially have a sample that is less than 1 millisecond in length, it could happen. I need to make sure that I can cope with numbers smaller than 0, or indeed numbers between 2 integers. We cable the info's output into the right-hand inlet on the multiply objects, because that will set the value that we're multiplying the left-hand inlet against without doing anything. So it doesn't change anything. It just says multiply against this value. And then the dials go into the main inlet on multiplies, so that whatever the value is set to will work. And for that reason, we would have to ensure that this number from info goes into the multiply object before anything else happens, so that the dials actually work. Since we've already got a sample loaded, what I need to make sure of, because these won't do anything. These won't do anything right now. Thanks. That I grab this data from the info object so it gets sent down to the multiplies, and then the start and end points will work in a meaningful way. Let's just make sure this works. I'm going to turn the volume down. I don't know how it is on the stream, but I'm getting a little deaf every time that Thames Television ident comes in. Okay, it works, but it does go a bit weird when the start point gets bigger than the end point, which is interesting because when you click on the waveform display, you can make the start point smaller than the end point, or vice versa, and it will just invert the two. But the operation here is different. So as soon as the end point and the start point are the same, the selection doesn't really work. So what I could do is call the end control length. Okay, make the start point and the end point just a certain amount after the start point. I'll just start getting into some pretty head-scratching maths, because I wouldn't want to have a situation where the end point had a value bigger than the total size of the sample. How do we do this though? So if you can tell, this is a little bit I haven't prepared for, because I only just thought about it. So let's first of all call this length. Okay. the length can be potentially any value from just after the start point to the full length of the sample. So the start point could be 0 and the length could be the full length of the sample, but it can't be longer than the sample. So we definitely can keep the length dial having a 0 to 1 and being multiplied by the total length of the sample. But we always want to make sure it's longer than the start point. So what I could do is, rather than send the length straight into the endpoint on the waveform, is I could add it onto the start point. So we take the start point and the end point, or the length rather, and then we send the length into the waveform object, and that will give us a sample length. And now, I guess the problem is that the sample length can be larger than the total length of the sample, but also it's not changing dynamically with the start point. It's staying in place. The reason it's not changing is because the maths object doesn't work like that. The plus object doesn't work like that. What's going on is that as I'm changing the start point, it's changing the number that I'm going to add, but not actually changing it. I mean, what I could do is switch the numbers over like that, and then what will happen is my length control won't do anything, but the start point will, and now it's working as you might imagine. So if I make the length short, when I change the start point, the whole thing moves around, but when I change the length, it doesn't update. Welcome to Max programming. How do I fix this? Well, there are a number of ways of doing this, but basically if I output the value and then force the maths object to update, which I can do using a trigger object. Whoops. Let me just build this part and then I'll explain what's going on. So our value goes into the top there, it gets spat out into the maths object, which then gets banged. I'm going to test it to make sure it works. So I can change the length and the start point. What does this do? This is the subject here is a trigger object, and what I've done is I've said when you get any information, first of all, output the information from here, which happens to be a floating point number. So F means float. So the first thing is it will send out the number into the maths object. And then the second thing is it will send a bang command to the left-hand inlet of the maths object, which will force it to output its current contents. So every time you turn a dial, the TBF object will first of all send out the value that you just created with the dial, and then send a bang command to the maths object to force it to output its contents. Effectively, what we're saying is every time you change that dial or that dial, update the sum. So that now I've got a length and a start point that can both work together. Let's see how it works. So it's pretty fun. And I could fix the problem where the length dial will continue on after the end of the sample, but actually it doesn't make a difference, because if the length is way beyond the end of the sample, the buffer's only so long, so the loop will still only happen from the end of the buffer to the beginning of the start point. It's very complicated, but that now does a thing. I quite like the idea of associating that with the dial on my controller and turning the dial and being able to kind of manipulate the sample like that. So if we add these two things to the presentation, and stick them in a good place on user interface, which I'm not paying a whole lot of attention to at the moment. Save, close. Let's load a sample in. Let's load a different sample in, see how that works out.
More snow and bigger mountain, mountains, the mountains, bigger mountain, bigger mountains.
Cool. All right. Now, that's great. I'm going to add one additional level of functionality to this, and then call it a finished thing. And the extra thing I'm going to add to it is the ability to press a button, which could be automated or could be triggered by something from Ableton, and every time the button's pressed, have a new random start and end point generated, which is much more akin to what Kieran Hebden was doing in that video, where it was kind of clicking like a maniac with his mouse, but without having to click like a maniac with a mouse. Okay, how do we do that? Well, there's a couple of ways to achieve it. Probably the smartest way would be to use the random object and have it do something similar to what the dials are doing there. So the random object will generate a random number from 0 to 1 less than a number that we've given it, and it's the arguments there seem to imply that it works only as an integer random number generator. That's something that I could perhaps figure out later, but like, for example, if I type in random 10 and then watch the output, so I print the output from the random object. Print. Every time you bang it, you get a new random number. 0, 6, 0, 9, 0, 7, 3, 5. From 0 to 1 less than 10. Out of curiosity, I wonder what happens if we initialize that as floating point. Okay, so it'll only work in int. Fine. Since we're working with quite large samples, I think it's probably okay if we clip the play position to the nearest millisecond for now. So I'll do that. And so what we do, if we wanted to change the start point randomly, is we'd send the total time into the random object. And then when we load a sample,
more snow and bigger mountains.
The random number generator will be filled with a range from the beginning of the sample to the end of the sample. If I made another random object for the endpoint, we think about this in the same way as the dials. It's not end its length. What I could do is just say, I don't want to ever play back more than, I don't know, 500 milliseconds. So I could say random 500, and then I can send this one to the start point, and I can send that one to the end point. And it doesn't matter that we've got other cables there overriding those values. Max will let us do that quite happily. But we need to make sure we add the second random to the first one, so that the range is after the start point. Okay, so we use add. Doesn't matter whether it's floating point this time, because neither of these numbers are floating point. We add that one to that one. Now there's this problem again, isn't there? Because what's going to happen is if I press my randomize button here, is it's going to randomize both these values. This one's going to get stored, but only that one's going to output it, which might cause a problem. Let's see what happens. So what I'll do is send my first random into the start point, and then that one plus that one into the end point, or rather length. So now every time I press a button, I get a new random start point and end point, or rather a random start point and length. But notice sometimes when I press the button, the length is far bigger than 500. That is more like 1,000. That one's huge. That's definitely not 500 milliseconds. So something weird is going on. The weird thing that's happening is that, first of all, or sometimes what's happening is that the random 10 is sending out the maths of the random 500's previous value with its current value. So it's kind of like the second one's one step behind. So we need to make sure that they're synchronized. We could do this thing again. So we could force the second random to make the sum work as well as the first random, but then I'll get two random numbers, which is not what I want. So what I'm going to do is use my trigger object again, but this time I'm going to trigger two bangs from this button here. The first one, this one, is going to set the length, and then the second one is going to set the start point, and trigger the calculation. So the two random numbers should be in sync. That's not working. Shockingly. This kind of stuff always happens with Macs. Is getting the order that things happen in right is actually a little bit difficult. It's even worse. It's doing something though. Okay. To get to the bottom of this problem, which I should say, when I tried this earlier on, I didn't have this issue. So I've done something different. To get to the bottom of the problem, I'm going to do a little bit of debugging. I'm going to use the print object. And I'm going to give the print object a name so that I can see the order that things are happening in, and hopefully try and get some way to solving my problem. So when I press this button, what happens? I set the length and then I set the start point. So it's happening the wrong way around. So let's set the length and then the start point. There we go. That looks better now. So when I press the random button, the length, okay, it's a number that is the start point plus whatever the length is. The difference between those two now shouldn't ever be more than 500 milliseconds. So it can be a bit of a challenge sometimes to figure out when things don't work as you might imagine, why that might be. So a combination there of using trigger objects to force when stuff happens in the patcher, and print objects to print out the results of things, debugging effectively, but seeing when they happen. Kind of enables me to solve the problems. And now the debugging process is finished. I can take my print objects away. That needs to be a live dot button so that I can automate it. And that needs to go up here. I'm not really paying attention to the size of it, but we'll call it random. Okay. Random. Where did the button go? Ah, I didn't add it to the presentation because I'm a fool. Add the presentation. Save. What a mess. Okay. Okay, great. That's awesome, and I like it. So let's just recap there. We have a device which allows us to load a sample, and it allows us to click in a waveform display, select start and end points. It allows us to change the start and end points of the dial, and it allows us to randomize the start and end points. Wouldn't it be fun if sometimes the sample went backwards? Now, to make a sample go backwards, we simply send a -1 into SIG. So SIG could be either 1 or it could be -1. Let me demonstrate. So if we put our familiar, actually let's put one with vocal in, put this sample in here.
Big amount, 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 big mountains. So sending -1 to the SIG object, just it makes the turntable go backwards. You can also send different values to SIG. So if you set it to 0.5, you'll get half speed playback. If you set it to 5, you'll get really fast playback. So let's make use of this information. What if every time that my random button was pressed, it also randomized playback speed? So what I want is a random number that goes from, let's say, -2 to +2. Now random goes from 0 to a number, doesn't it? So like if I said random 4, I'll get 0, 1, 2, 3 from a random 4. So if I take away 2 from that number, I'll get -2, -1, 0 and 1. So actually what I need is a random 5. And every time I press the button, what I'm going to do is take away 2 from that value so that the result will be either -2, -1, 2, 1, or 0. Don't actually care about the 0.
because I don't really want the sample to stop, but I'll leave it in for now and we'll see how this goes. So that will be randomized from my main random button, and the value there will be sent into my SIG, so that when I press start, apart from sometimes the random number is 0, so SIG just turns the playback off. If I wanted to filter out my zeros, I can use an object like root. So if I root 0, what it's going to do is look for zeros and then output zeros from here. But anything else would be output from here, so I can simply, it's not there, is it? It's there. I'll just monitor the number down here, and so that will now randomize between 0 and 5, which will create 4 random numbers. We'll take 2 off that range, so it'll go -2, -1, 0, 1, 2, but anytime there's a 0, we'll ignore it because I don't want the sound to stop. It's a bit coarse because 2, 1, -2, -1 are all quite far apart in terms of a range. So if I wanted to make that range a little kind of more fine-tuned, I could just make this random number bigger. So if I make it random 20, all right, it's probably a bad idea, isn't it? I actually want it to be between 0 and 5. So I need to divide that by some maths. 4 or 5 to 20, aren't they? So divide it by 4. Floating point. And then take away 2. Floating point. We'll try it without the root for now. What it should now do, every time I press random, pointing at the screen like that's going to help, is it's now doing numbers between -2 and 2, but in 0.5 steps. So I've got more values. So it's kind of random, which is cool. Something to think about there is that right now, every time I press my button, the thing is completely random. So it randomizes every single time. What if we were to say, I only want it to randomize sometimes? And how would that work? Well, this is a step into what is kind of more clearly a kind of generative approach to music, which isn't to say it's random, it just always does something random, but that you can set a chance of it doing something. Like maybe say 20% of the time it randomizes, the rest of the time it doesn't. How would we do that? There's a really simple way of doing it. For example, if I use a random number generator from 0 to 100, or 0 to 99, so it's got 100 values. And I say I'm going to only use a certain range of numbers from that range. So we use the select object to do this. So let's say we say select. It's not the select object, is it? Let's say we use a less than object, and we type in less than 50 for argument's sake. What this will do is if we have a number less than 50, we'll get a 1. And if we have a number greater than 50, we'll get a 0. So it's kind of like a is it true or false thing. We can see the 0 and 1 by putting a toggle downstream from there. So if I press my button, sometimes the random output is less than 50. Sometimes it's greater than 50. So it's actually, because it's random, every time I press the button, there's a 50-50 chance of this going on or off. But if I make that less than 25, now when I press my button, there's only a 1 in 4 chance that that's actually going to do something. Because when you create a random number from 0 to 100, 0 to 99, 1 to 100, and you say, is it less than 25? There's pretty much a 1 in 4 chance of that being true, because 3 out of 4 numbers in the range 0 to 100 are greater than 25. I lost my train of thought completely there. Okay. Where am I going with this? Well, let's see. I could say every time I press the random button, there's a 1 in 4 chance that I'll get a new random speed happening. And to do that, we simply make sure that we are selecting ones from this stream of numbers here. And that will generate a bang every time a 1 comes along. And then we can send that into this other random number generator here, so that we can say that we'll get a new speed every 4 presses of the random button on average. I need to make sure that that goes to there, otherwise nothing's going to work. So now it spends longer in each kind of zone of randomness. All well and good. I also need to make sure that I've got a reset button that resets my playback to normal. So let's copy that and copy that. Call that reset. Send that to that. Plug that in there. Check the presentation. Move my buttons around a bit. Great. Now I can load in a sound.
More snow and bigger mountains. More snow and
I can click on it. I can change.
Can you find mountains?
Change the start and end points of the dial, or I can press my random button. Got some zeros in there. All right, one final thing for the presumably 3 people that are still watching this. How could we make this work on a live input? So rather than loading in a sample, a method for doing this that works on live audio. Well, it's actually quite easy to do this. We simply use the object record, and that object goes into our buffer in stereo, and then the input to record comes from the plugin object, which is the input from the channel, and then we set record going by giving it a toggle switch, live.toggle. That'll start recording going. Let's see if this works. So right now this is sat on an audio device. Inside the device, the input goes to a record object and the output comes from the buffer. So it's not going to do anything if I put something on the track. So let's put a sample on here. Obviously it's not doing anything, because although the audio is going here, it's not actually going anywhere else. But that audio is going into the buffer, or it's going into this buffer here. The catch is, before I load a sample into the buffer, it won't have any length. It will be there, but it won't have any space in it to record audio. So what I need to do is make sure that I initialize the buffer with a certain length. This is actually going to work. Let's see what happens if I press this record button. Interesting. That's because that's not the buffer. That's the buffer. Duration 1 second for now. Now what's happening is every time I press this button here, I'm recording audio live in from the track. James Brown. This is fun though. This could be not James Brown. This could be a mic. Like, say I used my microphone, hello, to record stuff into the buffer. My buffer's playing, I think. Yeah, looping is on. So if I say something, I've got a monitor on. So if I say something, we're actually able to do this operation on audio coming in live through the patcher. I'm not going to demonstrate much more about that because it can get a little bit confusing, but you can pretty much see the limitation of what I've done there, which is that I can only record 1 second of audio. So if you wanted to make this so that, say for example, you could record a bar of audio, which would loop naturally at a tempo, what you'd first of all need to do is work out how long a bar was, and then make the buffer that big, and then you'd get a bar. So if you put a drum loop in that was a bar long, it would work like that. And then what you can do is click on it, and it will be the correct length. I kind of think, to be honest, that I've done something here that's not really about sort of bars and beats in that way. It's more sort of a random sort of generative tool. So I'm not so fussed about that. But if you wanted to do it like that, that is possible. I'm going to make this a little longer. It'll clear the buffer when I make the length different. Then put my record button in here. Run out of space, haven't I? And that's the whole thing, which should allow me to A, load in a sample, as advertised, but also should allow me to overwrite that sample by pressing this button. La 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 la. Ooh dee da 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 da. And work on live audio. Okay. Before I disappear, let's see if there are any more comments. Of course there aren't. There was quite long, that, but I'll probably kind of move on from the whole Max for Live thing for a bit, or at least the really kind of in-depth stuff. So let's just really quickly recap there. What I've done is made a patch that allows me to load in an audio file using a buffer, play it back using a groove. I've created a waveform object set to the same buffer by its name to control the start and end points for my groove object, which I could do graphically with the mouse by setting the mode to 1. I'm also able to, by getting how long the sample is from the info object, I'm able to adjust the start and end points with the dial, and I can randomly adjust the start and end points with a random number generator. Some of this stuff here is to do with just making sure that the numbers are generated in the right order. I can also randomly change the playback speed from anywhere between double reverse speed to double forward speed, but there's only a 1 in 4 chance that will happen, because I've randomly, down here, I'm generating a random number up to 100, but I'm only using a quarter of those numbers. So every time I press the random button, there's a bit of a chance that I'll get a new playback speed, and I've added a reset button to fix that. And finally, I've added back in my plugin tilde object, which goes into the record object. That records into the buffer. It's got the same name. And that's controlled by a start-stop switch up here, which I have not labeled, which I will now do. There we go. The Fortet Slicer random audio slicing generator thingy. Lots to unpick there. What I'll do is, oh dear, what I'll do is share the device on the VLE so that you can download it if you want. You want to play with it, unpick it and see what I've done. All right, I'll leave it there for now because I'm starting to really lose my train of thought. But I hope this has been useful.